Hello and welcome to my YouTube channel. In this video, I'll be discussing compound angle identities. What will this video cover? This video will firstly cover the points of compound angle identities, secondly, the sine compound angle identity, and lastly, the cosine compound angle identity. Okay, firstly, what is the point of compound angle identities? Obviously, there are more than one reasons, but one of the biggest reasons is because it gives you a different perspective. Trigonometry is a field in maths where there is, well, in fact, that this is applicable for all fields in maths, but particularly in trigonometry where there isn't one way to look at a question. There are different ways or different angles you could take to approach a question, and they could all be right. Now, say you had something like sine of whatever this angle may have been, but you don't know what to do with it. Now, what compound angle identity provides you with is a different way to look at it. Now, you don't have to look at it as sine of a particular angle, but rather sine of a times cos of b, given you divide that angle into a and b, and then you either plus or minus cos of a times sine of b, depending on which one you started off with anyway. And similar thing applies for cos. First off is the sine compound angle identity. Now what the sine compound angle identity basically says is, given sine of an angle, whatever that angle may be, if you were to divide that angle into a sum of a plus b, then that will be the exact same as saying sine of a times cos of b plus cos of a times sine of b. So let me give you an example. Say I had sine of 90 degrees. That's what the angle was. The angle was sine of 90 degrees. Then it doesn't matter what I divide a and b to be. I could divide it to be 50 and 40. I could divide it to be 60 and 30. Anything whose sum will give you 90 degrees you can use. So I'm going to use 60 and 30. Then that means that if a is equal to 60 and I let b be equal to 30, then sine of 60 times cos of 30 plus cos of 60 times sine of 30 will give me the same value as sine of 90 degrees, which is just simply equal to 1. One thing you should note about this form is that you should try and make sure that your answer is in the format sine cos sine. It follows this particular order, and if you put it in this order, then it'll also be easier for you to note where your a is and where your b is, because the pattern is this. If you have sine of an angle and you divide it up into two angles, right, then the first angle will be the first number always in each of these pairs. So there's a sine cos pair and then there's a cosine pair. The AB order stays the same. AB, AB, AB. That remains the same. What does change though is that it goes from sine cos to cosine. So sine cos, cosine. Make sure that you order, if it was for example cos of b times sine of a plus cos of a times sine of b, make sure you switch your order up such that you have sine cos cosine and that it goes ab ab ab. Another thing you should note is the sign over here. So over here the sign is a plus. It remains the same over here as well. This is different from the cos compound angle identity, because when you're dealing with sine, the way I like to remember it is, for sine the sign stays the same, whilst for cos the sign changes. And the same principles that were applied up here apply for here as well. And over here you can see your sign over here, the sign stays the same. So over here it's a minus sign, which means that over here it will also have to be a minus sign. A relevant example. We're asked to simplify the following. Sine of 90 degrees minus x times cos of x plus cos of 90 degrees minus x times sine of x. Okay, so firstly, are we dealing with the sine compound angle identity or the cosine compound angle identity? Well, we see a sine cos and then a cos sine paired together. So we know that we're dealing with the sine compound angle identity, and we can see that's following that AB AB format. So it means that we don't need to switch anything around or whatever. We just have to take what is given over here and turn it back into this format. It's either sine A plus B or sine A minus B. Now I see a plus sign in the middle over here, which already implies to me that I will be dealing with the first example over here. There won't be a minus in the middle. So I take sine of what is essentially A, 90 degrees minus x, and then I add that, because of this plus sign over here, I add that to the x over here. Now I can drop the brackets and I see that the x's cancel out, which just gives me sine of 90 degrees, and you should know sine of 90 degrees to simply be equal to 1. Next, we have the cosine compound angle identity. Now, the cosine compound angle identity differs from the sine compound angle identity in two ways. The first is, whereas in the sine compound angle identity we'd have a sine cos sine pattern, over here we have a cos double cos, and then double sine, cos sine sine. And the second thing that the second way in which it differs from the sine compound angle identity is the fact that the sign changes. Over here we initially had a plus, but when we expand this we find that we have a minus sign. Over here we initially had a minus sign. When we expand it we find that we have a plus sign. Those are the only ways in which it differs. The AB pattern remains the same for both the plus and for the minus scenarios. A relevant example. This question asks us to simplify the following: cos of x plus 70 degrees times cos of x plus 40 degrees plus sine of x plus 70 degrees times sine of x plus 40 degrees. We're obviously dealing with the cos compound angle identity, and we see that it's already in the cos sine format, and it's A, B, B. So we don't need to change anything in terms of order. All we need to do is identify which specific one of these two scenarios we need to apply and convert it as such. So over here I can see that I'm dealing with a plus sign, so I know that I'm dealing with this second scenario where the plus turns into a minus sign, and I subtract A from B. So I've got cos of A, x plus 70 degrees, and now subtract b from that, which is x plus 40 degrees. Now I'm dealing with a minus sign over here, which means that when I drop these brackets, I need to multiply this x by -1. I need to multiply this 40 degrees by -1, which will then give me cos of x plus 70 degrees, and that'll be minus x, and that'll be minus 40 degrees. Yeah, I don't need these brackets over here. Okay, so what's x minus x? And that means I no longer have x's anymore, and then now I have to do 70 degrees minus 40 degrees. 70 degrees minus 40 degrees is obviously 30 degrees, so I've got cos of 30 degrees. And if you know your special angles, then you'll know that cos of 30 degrees, well, special triangles, will just be equal to √3/2, and that's your final answer. If you found this video helpful, please don't forget to like this video, share this to anyone who you think may benefit from it, and also subscribe to my channel. Also, don't forget to switch on post notifications in order to be notified when I release my next video.